just using
Okay, good evening everybody. For those who don't know me, I'm Sean Lincoln. I am currently the president of Reast, and I'm here to give a presentation on, I guess, a bit of a fast track into the Arduino. I'm sure it's a term many people have heard of over the years. It's been around for quite a while. I expect many people have seen it and tinkered with it, and others saw it in the early days, thought, bit of a fad, walked away. It's worth having a look at though, I think you'll find. What is the Arduino? It's a project that came out of university in Italy back in 2003. Essentially it was a cheap introduction into doing what the Americans call physical computing, connecting devices to in the real world to a computer to do things with. Cool thing I found out, it's named after a bar where the founders got together to talk about the project. I mean, it's almost Australian, I guess. The original version they put out was based around an Atmel 8-bit CPU, basically a small microcontroller with some basic peripherals, a serial port on there, support for I2C, peripherals, SPI, and a mix of analog and digital I/O. So a range of capabilities to either talk to simple sensors or more complex chips as your skill set and your needs grew over time. It's also interesting in that it isn't just a board. You think back to when the Arduino first hit the market, you go to eBay and buy like a little board with, say, an 8051 microprocessor or any other kind of CPUs. You bought these things and then had to go, okay, how do I do something useful with this piece of stuff I bought? The Arduino made this a lot easier because not only could you buy the boards for doing your project with, it came with a very good software development environment where pretty much everything you needed to get up and running from day one was there. So unlike the old days when you get your editor, your compiler, your linker tools, your relocators, your downloaders, debuggers, you have to work out which tools to pick, which libraries to jam together to get your right up and running. This is basically a tool you can download, install on your PC, and start doing stuff with. It's all in that one package. Another nice thing about the Arduino IDE is they just give you the basic things like an editor. They give you examples built into the software set itself. So rather than being like many tools, you start with a blank page and then start working what to put on there. You can pick an example in the IDE that looks close up to what you want, and then make change to it. So it gets you up and running very, very quickly. So a lot of that groundwork's taken care of by other people, and you get into thinking about how you solve your problem, how you build new thing, rather than how do you fight the tool to make it do what you want. It has a massive online support presence for support for ideas and tools. 15 years on the internet is a very long time for people to come up with cool things to do with technology and ideas. The toolset itself has been growing slowly. The technology behind it has been growing fairly quickly. While it supports the usual AVR microprocessors, other chips are being supported in that environment as well. So if the AVRs aren't doing what you want, there might be another chip out there you can use in the same environment which does that and more. I've got an example I'll talk about here at the end, but there's some other thing worth looking on Google for. Like I said, this is very quick to get up and running. Literally, you download the software from the internet, install it on your PC, plug the Arduino into your PC, tell the Arduino environment what kind of things plugged in, and start doing stuff. It's one of those things you can go from nothing to operational in less than half an hour. What can the Arduinos do? Like I mentioned, they're normally a 5-volt device. There are some that can do 3.3 volts if you're using different technology. You don't want to worry about things like level converters. They have analog I/O, so you can read a potentiometer. They can do analog output through PWM to generate varying voltages between 0 and 5 or 0 and 3.3. I2C is one of those really cool protocols that takes 2 pins from your microprocessor and lets you put on a bus a whole range of different kinds of chips. You can get real-time clocks that talk over I2C. You can get I/O expanders to give you more digital I/O. You can get, I've seen chips that will talk to an LCD display over I2C. You can get rotary encoders, all kinds of gadgets where you can share those 2 pins on a microprocessor and do really interesting things with them. It also does RS-232 on the chip, so it doesn't big bang like some chip processors. It actually has a proper UART, so it can form bytes neatly without consuming processor resources. So you can do serial I/O to your host PC whilst doing other things at the same time. It makes very good use of the processor resources, and your code looks like it's faster than it actually is. Limits. These are small devices. Part of the giveaway is you should look at some of the part names in here. For instance, the Atmega 328 has 32 kilobytes of memory for storing your program. It's kilobytes, not megabytes. Now, that can be quite a lot if you're working in assembler or very small programs, but you're not going to run a word processor or a web browser or talk to the internet with that amount of capacity on chip. Or sometimes you can talk over Ethernet, but you need another chip to do the heavy lifting for you, and you talk to it and it talks to the network. So, kind of clever. There's not a lot of RAM on these things. The Arduinos we'll show you here have about 2 kilobytes of RAM. That's for the stack, for temporary variables, for things like buffers, for input from users, for forming information with displays. 2K is not a lot of memory. So again, it's one of those things where when you're writing code, you look at what's going on in your code and you're economical about what's going on. Or you just get a bigger chip than the one you're using and work your way around those limits. I/O options. This is one of those areas where if you're doing things, you'd go off and you read the data sheets of the parts you're working with. The Arduinos, there are 5 volt parts and 3.3 volt parts. If you want to connect it to some interesting kind of chip, read its spec. Is it 5 volt or 3.3 volt? If they're the same, it's basically you connect the two and it's easy. If you're a level converter, it's something to be aware of. Feeding 5 volts and 3.3 volt parts and vice versa can let the blue smoke out and can do weird things. You're going, why is this not working? Small detail, but it can be quite challenging when you miss at 3 o'clock in the morning. I think we've all cooked chips that way. I certainly have. More on that. Speed. The Arduinos are AVIOs are RISC processors. They can do 1 instruction per clock cycle. Typically, they're either 16 megahertz or 20 megahertz parts, so they can run between 16 and 20 megahertz. They are, however, an 8-bit processor. That means that anything that uses big numbers takes a lot more work than small numbers. So dealing with characters is easy. Big numbers like counting a frequency or something, that's bigger than 8 bits. That can take a bit more work on the processor. And again, you may want to use a bigger CPU. Why do you use it? I keep these in my toolbox for when I have an idea I want to jump on and do something about. Often it's a case of, if you've got the tool chain set up on your PC, just plug the IDE in, plug the chip in, and have a tinker. See, what does it work? Will it fit in the chip? There's a lot of good tutorials on YouTube and other places on the internet if you want to see how people have done this work in the past, rather than work it out from the basics. Do a bit of Googling and see what other people have done. Over the past 15 years, a lot of people have done some really cool things in this space, and often you'll find there's something that's close to your idea you can take and tweak and build and make better. So again, you can build other people's ideas and start with good building blocks rather than being a blank sheet of paper. Do I need to read the spec sheets and get caught up in a lot of that detailed mechanics that can at times, slow you down and make the idea a bit more difficult than otherwise be. There is a lot of example code out there. Part of the Arduino website is the Arduino playground, where people get together and share ideas and solutions. They build on the ideas others have come up with. The libraries are available on the site, and you look at some things there, there's some very clever things going on. There are a lot of manufacturers out there who have worked out that Arduino is a place to sell stuff to. So they will not only sell things like little boards with chips on them, they'll often accompany them on their website with Arduino library examples of how to take them and use them. A really good example of that is a company called Adafruit in the US. They resell their parts through the likes of Tronics Labs, Little Bird Electronics, all kinds of places on the internet where you can look on their website, find a part that will do what you want. They'll have instructions on how to make the part work. They have the libraries to the Arduino, how to go through and do it, and examples showing you how something actually hangs together and works. Again, that's one of the beauties about the example components of the Arduino IDE. When you download the libraries for these chips into your machine, the examples come down with it. So you can pick a part, download the library component, pick the example that shows you how to use that chip, and then start tweaking it to make it do what you want. Again, very, very quick to build things. This again is still using just that one software package to install it. The IDE has the ability to go up and search for a lot of libraries and functions. So if you've got a chip you want to play with, you can often go into the Arduino library, say, go through the libraries and find me something that deals with this part. And it'll come back, oh, I found all these things. Which one would you like to try? And you've got everything from the inbuilt libraries to third-party libraries, which are often different, better, or improved in some strange, interesting way. I'll show you one of those later on in terms of where someone did it better than the original guys, and it's really, really nice. They're cheap. I have, at the end of this presentation, in response to good questions, I've got some giveaways. I've got a couple of packs of these little guys, so pay attention. These cost me $3.40 something via AliExpress. It took 4 weeks to get here, but I mean they're less than the cost of a cup of coffee. Doesn't mean
free postage.
Free postage, yes. Too true. I love that particular line. They are so cheap that one of the things you buy half a dozen, put them in your box of bits and pieces, hopefully labelled so you know what's inside the little blue bag. And when the idea comes along, give it a shot. If you destroy one, it's a little annoying, but I mean it's not like it's a major hit pocket. Not like you're destroying a laptop or anything like that. So again, it's one of those low risk, low panic. I'll tinker and see what happens. Went through the cost there. These ones from AliExpress, $3.50. I was out at JK yesterday. You can buy them off the shelf tomorrow without any drills for $29.98. Or if you want to build an Arduino yourself from scratch, they'll sell you the bits and pieces there as well. You can get the microprocessor for $12.95. Again, immediate stock, immediate gratification. Or you do what I do, buy from AliExpress, and when they turn up, I'll use them one day, I'm sure. Those little bags look the same after a while.
How many do you actually have?
I don't quite know. I have some.
Sounding like a little bit of an obsession.
N plus one.
I've got enough to give away to my friends who have questions. Over the past 15 years, there have been quite a different number of incarnations of these boards as people have added better processors and tweaked them in some new and novel way. You've got the classic bare bones ones, you've got the breadboard ones, which I'll go into here a bit. You've got ones built at Mega 2650. I think some people use them some of those antenna tracking projects where they have more I/O, more memory for your code, more memory for data, so they can do more complex things than the smaller Arduinos can normally do. But again, you don't need a full-blown PC to do what they're doing. And the versions made by companies other than Atmel, they're even better. Got some here to show off. This, if I bring it up on the screen, this is one of your original style of Arduino. So you've got the Atmel 328 CPU here. This one's in a socket, primarily so if I destroy it, I can yank it, put a new one in and not write the board off. I'm cheap, $30 the board, I want to get some life out of it. There's the USB connection here. Here in the very dark bit, there's a chip which takes that USB connection and turns it into RS-232. Many Arduinos do that. There are, however, some that don't use that chip. What they can do is they can do the USB function on the AVR microprocessor itself. It's not so much doing that because it makes the part cheaper. It's because they can do some clever things. To my computer, this is a serial device. But the ones that do USB on the chip themselves, they can be something different. So you can have a very slow, very small flash drive. One thing people are doing is using them to make them to be a keyboard. So you can have a device with a whole range of buttons, knobs, and controls built with one of these USB-based Arduinos that your computer thinks is a keyboard. So for instance, the application might be for like a physical control panel with software-defined radio, where you want the big knobs and buttons and toggles. If the application on your PC be driven by keystrokes, you just basically build the Arduino, connect your knobs and dials and so forth, and return them, have them send keystrokes back to the PC. Gaming people like them for custom keyboards, for do something quick and dirty. And again, the old macro idea, but with better controls and just another keyboard on the button on a keyboard. Sorry. I mentioned the bigger ones. This is one of those 2650s. If you look at them side by side, I'll get these here. They're basically the same, except that you've got a lot more connectors around here. So the boards you can put on top of them can have more digital connections for more chips or do more novel things. Again, for those people who have a bigger project that a small one like this can't deal with. Another one of my favourite form factors for Arduinos . If you're so inclined, you can build your own Arduino from scratch. Now, I wouldn't recommend you go off and try to build something like this, but if you're comfortable writing code for the Arduino environment, you can develop it using all the tools on your desktop PC on one of these larger boards, and then you can download the code into the chip, pull it out and build it straight into the gadget you're working on. That could be useful for things where you're never going to go back and change the code again, or something's going to go in a small box because you have space issues. For example, the last one of these I built was for a box that plugged into the infrared input socket on the back of a stereo and basically faked the behaviour remote control. So a computer plugged in, the computer was driving the stereo receiver. The stereo receiver was an infrared remote control, and it was basically a lump in a cable. I think it was one of those little level converter boxes. I've got to just repurpose the container. Being cheap, I know. This one I've shown you before. These are one of the tricks around the cheap ones is that the small package means they can make them below a price point, but you notice that the actual headers go down the long sides. I have seen there are some other small ones people are putting out where they decide to make them even cheaper by making the board smaller and putting pins along that edge there. It's great if you want a cheap one. If you're going to put it into a breadboard, you're going to have some problems because that bit on there just gets in the way and you lose bits, and it's just, you know, this is a nice form factor I've found. Moving on.
What's the name of that one, Sean?
That
last one?
Sorry?
Does it have a specific name? Yeah,
This is your lovely Arduino Nano.
Nano, right.
So the Nanos do come in different packages. So it's one of those things, if you buy them on eBay, look very carefully at the photographs. But that deal form factor is probably one of the better ways of getting the small cheap ones because they work on pretty much anything you're plugging them into. We talk about Arduinos, then we talk about shields. They like making up these names for things. The shield is basically a circuit board, a daughter board that plugs in top of the Arduino. They are basically there if you want to have someone who isn't comfortable soldering spin up and do something useful quickly. Again, this is one of those things where there's a whole range of options. Where is it? Here's one that's unfortunately quite obvious. It's a breadboard on a shield. So again, plugging a small dual package or a small analog circuit in there, plug them in, jumper wires, you're up and running.
So there's the process underneath that.
Correct. To demonstrate, you can see they've got pins and sockets. Literally.
Oh, so that whole thing is the shield.
Yes, so this board,
Yeah.
that becomes the shield. So
Right.
again, you can plug ICs and so forth in here, jump from there out to the edge, and test something out. They can be useful, again, like those small modules you want to just plug in, do some quick software experiments, understand how the chip works, and then do something a bit more polished if the idea looks like it's going to be a good one. Other ideas for shields? Other of my favourite ones? Basically a board with lots of holes. Yep. But there are of course the usual minimal traces in here to take the pins from the headers and route them somewhere useful so you can then solder onto them without having to jump through. The headers that they use to connect, essentially the key is they've got these very long legs on them, so the idea is you put them through one side, solder over these so you get the legs coming out the bottom. Not too hard to hunt down these days, everyone on eBay sells them, but again this one, that was a purchase from my friends at JCar again, complete with the JCar compartment on there.
So that's a make your own shield.
This is I want something that isn't going to have the parts falling out like one of these. So that's probably tinker around the workbench. This is I've got an idea, I'll solder this, doesn't fall apart in the back of the car or whatever. Before you go the whole hog and maybe build a whole printed circuit board and assemble as a discrete unit. But again, that on one of those will basically be enough. The other cool thing you'll notice, these things stack. So you can actually have breadboards on breadboards on breadboards. So I've seen people do projects where you'll have the Arduino, you'll have a shield with a micro SD card holder on there, so you can put some expanded memory in there, and maybe a GPS module on top of that, and maybe, I don't know, a cellular modem module on top of that. It starts getting a little bit complicated, work out what are all these pins being used for, and are they going to conflict with each other? Also, the other problem you've got with these is, it's a USB connection. How much power can the USB connection provide before bad things start happening? That can be both practical and software and hardware. When you connect the USB device to your computer, that device tells the PC how much power it's going to draw. And if the PC decides that's too much, it won't power the device. Or if you pull more power than you say, it can blow the fuse on the USB port. You've generally got to turn the machine off, let the fuse reset and try again. It's generally, I found, better if you're going to do something with shields. You may have a DC input socket, use the external power supply and avoid giving your computer a hard time. It's a lot harder to fix and repair.
So you can have both plugged in at the same time, the
Yes.
USB and the DC.
And there are, of course, as you expect, people with shields with like batteries and chargers, so you can do it, charge it on your PC, take it away hands-free. 15 years gives people a lot of ideas for doing these kind of things, and they're kind of popular. The other fun shield I've got, which I must admit I bought and never really got excited about, this is the Ethernet shield. So you can actually use it to connect an Arduino to a copper network, as you would like your PC plugged into a switch at home. Funny thing about them is that the main brains of it, the microprocessor down here that does the Ethernet bits and pieces and TCP, is probably more powerful than the Arduino it's connected to. It's kind of like, yeah, I'm using a Ferrari to tow a Ford or something weird. The make your own Arduino, I mentioned that there briefly. Basically, to make your own Arduino, you buy a unprogrammed microprocessor normally, but JCar will sell you one which is already programmed, ready to go with the bootloader on there. To download the bootloader on the Arduino, you've got a couple of options. You can use a proper commercial programmer to download it in there. Some of us might have them and regret wasting the money. Another way you can do that is, for instance, with the breadboard Arduino shield I showed you, you can actually plug your unprogrammed chip in there, wire up the programming pins, and download from the Arduino environment a sketch to program the thing for it. So you get Arduinos making Arduinos. A lot of people do it, but again, it's one of those things where I can buy a Nano for less than the price of the microprocessor. Why would I buy the parts when I can buy the whole thing at a fraction of the cost? In JCar, you have the benefit of having immediate gratification. Walk in, buy it, walk out. But even many of the proper supplies, the best I've seen is $6, $7 for one of these things, just the processor. $3.50 for the whole package from AliExpress. It's how quickly do I want this stuff? Generally, not that quickly. Oops. Other development environments. I mentioned the fact that the Arduino IDE does an awful lot for you in that one package. It is, however, something which is designed for, I guess, a lot of novice users out there. So some of the more powerful functions you might find in a professional toolset aren't there. One particular thing that I miss terribly, unfortunately, is having a good debugger. There is no debugger in the IDE. Now, professionals say if you need to use a debugger to make code, you're probably not doing it very, very well. I do this stuff professionally, but I like having a good tool set as well. Our friends at Microsoft, their big Visual Studio toolset, which does applications for cloud and database design and so forth, they've got plugins you can put in there that let you use Visual Studio to program Arduinos. It does have a certain level of sense. I mean, the Internet of Things is taking off, and Arduinos have a space in there, and people like having one tool set that does everything. But you don't need it unless you've got a particular design for it. There is a web-based development environment for the Arduinos, which I have not tried, but the idea is so basically you can connect to their website and do its work inside the web browser. Kind of clever. You can see how that one goes. I like having my tools in front of me where I can unplug and do things, and if the power goes out, the laptop's still there, if the internet goes down, there's no more cat videos for the day, I can live without them. You can also, if you don't like using a graphical environment, you can use the old-fashioned text editor, compile, link, make. It'll let you do that. I mean, it's heavy lifting, but some people like working that way. Or you might be doing things in an environment where that isn't possible. I have seen people developing Arduinos on Raspberry Pis that are somewhere out there. You can do it rough, but you can do it. There's probably even more tools out there. 15 years, a lot of people think, I can do something better than these guys. Some people try and fail, some try and succeed. It's worthwhile having a bit of poke around to see whether your favourite tool set can talk Arduino, or if you don't want to go and use the Arduino tool, but you really should have a look at it. It is actually quite a nice, posh piece of work these days. So how do you make it work? It's really simple. Plug the Arduino in, start the program, tell it what the Arduino is, and start coding. And with such things, of course, I shall attempt to live by my own rule. So,
You sacrificed the goat, I hope.
I didn't read the fine print, I apologise. Okay, we don't care about that one right now, so a bit later. Let's pick an example, a nice basic example. Now, You can see it's on the menu with all the file open, file saved, so it's not hidden away, you've got to go looking for it, it's there where you want it. One of the basic ones that everybody uses is called Blink. Blink makes an LED go on and off, and you're probably saying, how incredibly boring and useless would that be? Well, it is and it isn't. If you've never done programming before, it's a great introduction. If you have done programming before, you can prove your tool setup actually works. That way you can swear at the software rather than the newfangled gadget you bought. I will pick my Arduino apart here for a bit. Now,
They're pretty robust, and they don't care about being worked on with the power on.
be a real man. Not 240 volt, what's the problem? Apologies to those people who don't go there.
It's only 5 volt.
Exactly. Now, some people may have done a bit of programming before, particularly in the C language, and if you've done any work there, you know it starts with a function called main. You start at main, this is where the program kicks off and then goes from there. The Arduino is a little bit different. It has basically the idea if you set up the hardware that you're working on, then you let the thing go off and do its thing. So you've actually got two functions to start running. One is set everything up, and then you run the loop function. The idea is the loop runs, then runs again, and loops again, and loops again, and keeps on running. It's a nice separation of functions. You set things up once, and then you just let it go. In this program here, you can see in the set. Well, I'll scroll down. This is the setup. Pull this up with these examples, stuff, comments that can go. In the setup program, we're basically saying there's a LED built into the board, and we're calling LED built in. The IDE knows different boards have that LED on different pins, and makes that easy for you by not having you remember which pin it's on. Pin 13, I think, on this board, but that's all we care about. And that pin is an output. We're going to send a signal to make it do something rather than read it. After we've done the setup, we go into loop. So it runs loop again and again. So here we're going to write the digital output for the LED high, so we're going to turn it on. We're going to wait 1,000 milliseconds, and then we're going to turn it off and wait 1,000 milliseconds. Incredibly exciting stuff. Now, the Arduino I'm using here is actually an Uno. This is a different board from ones that are getting for free questions. It's on port TTY-ACM0. Now, this can be sometimes be a bit of a pain to work out where they are. The IDE does at least list where the real ports are and have a stab at it. So if you can't find it on one port, just try another one. Don't panic, it'll be there eventually. Now, I'll move this up here a bit. We'll click on the Go button, upload. This is going to go up and compile that program right now, and it's going to upload it to the board, and it's going to be saying done. Now, I mentioned earlier the issue around memory. It did scroll off the screen, but up the top here, the compiler comes, and one of the things it does is tells you how much memory your program's used, so you can work out how close you are towards the point where you're going to have problems. So this little program is using 928 bytes. I have written smaller programs, I've written bigger ones. You have up to 32,000 bytes, and it uses 9 bytes of RAM for the variable, which is basically none. So it's pretty much running okay. Now if I cut across back to the other camera, whoops, where is it? You can see down here, little LED blinking. Now some of you may have seen it blinking before, going, ah, Sean, you're just faking me. So let's go back and do something different. Let's maybe shorten that and make it blink a bit quicker. So change the numbers. Minor change. That's gone and done. We're blinking quicker. As a breakdown of how you start up a very simple program, the blinks program is worth picking apart to understand. And again, to prove that everything I've built in the sheet is actually working. If that didn't change the blinking based on the program, I'd know I've done something wrong, and it's okay, don't blame the gadget, blame Sean and fix the error somewhere else.
Does the board have a reset button on it? So that you can,
Some
if
do,
something
some
goes
don't.
wrong.
I think this one's here.
Yeah.
So it'll pause.
That just starts the program off again.
Yes. So a reset's basically just shy of yanking the power out and putting it back in. A little bit gentler, especially when the USB connectors don't have a very high duty cycle. You do it too many times and you'll break something. Also, some USB sockets aren't very well soldered to the board, and that can sometimes be a bit frustrating. You go, oh, that came off, and I can't solder things that small anymore. Again, this is one of those classic, oops, boring, sorry, gone through that. Bit of show and tell. One of the things I thought I should do for this is come up with something a little bit more radio related, the blinky LED. I know people could do Morse and so forth, but I can't, so we're not going to go that path.
I should have brought them along. The phobia.
Yes! The Morse trainers, they were cool. Very popular.
Uses Arduinos.
Yep. The board I picked here is, as an example, is a clock generator that's connected to the microprocessor I'm using here using those I2C connections I told you. So basically 2 I/O pins. I picked this one primarily because of 2 reasons. Firstly, Larry mentioned he was looking at one of these things a while back, so hey Larry, here's an example to look at. Secondly, there's a gentleman who came up here a couple of weeks ago whose name I forget.
Chris HCH, 7
Yes.
HCH.
With a micro-bitx QRP transceiver, and buried inside this box was one of these chips to do the frequency generation. So I know these things are clearly doable in radio. And behind the little LCD display is an Arduino driving its brains. You can download from the internet the sketch for those Arduinos to drive the micro-bitx transceiver to see how it works, and to modify it if you can make it better, or make it do cool, fun things no one thought of before, or take someone's better idea and make it happen. These particular modules cost about $10 US, around $15. I got mine from a company called Tronics Labs here in Australia. You pay the 5-night delivery, it turns up the next day. Great, can't fault them. Just to do a few more interesting things, I've also put an LCD display on this gadget and a rotary encoder to make it do some things. Now, let me just flip across over here. Building this about 4 hours on Saturday, just around the garage having a general good time. 2 hours to make the code actually work. This is using other people's example libraries, not from the ground up, because I'm lazy and I avoid mistakes by using other people's proven work. This is a bit of a rough diagram. I did not do a schematic diagram of this because it's basically too simple to bother. But generally speaking, it's the displays connected using 6 pins. There's a library that you use in your sketch that says what function on which pins, and that's basically all you need to worry about. The rotary encoder, I'm using 3 pins, but I'm only using 2 of them to do anything real. The idea of the rotary control, you've got quadrature encoder, so you can work out how many steps in either direction, and a button you can press to indicate you're doing something clever. There'll be something clever later, just to get it working first. And like I said before, just those 2 pins to talk to the clock module. The clock module itself has 3 clock outputs. I'm just using one of them for this particular show and tell. There are versions that will do, I think, up to either 8 or 20 independent frequencies coming out.
Is that using I2C?
Correct.
Yeah. Okay.
So, let's unplug a few bits and pieces. What I've got here is just a bit of ground truthing. I've got a frequency counter sitting here to actually watch the signal coming out of it. So you can say, don't trust me, Sean. Don't trust Sean, just look at what the counter says. My $65 eBay special. Very proud of that. I can change the frequency output by 2 different ways. One is by using the rotary encoder. Turn it one way, the frequency goes up, the other way it goes down. But because the Arduino's got a serial port built in, I can also do it over the serial port, which makes it a lot easier to get interesting frequencies because you're stepping around megahertz hertz basis on the rotary encoder. You take a lot of time to change stuff. Where is it? Oops, let's go this way. Okay, so if I unplug and put that guy over here, and this guy back into focus. Oops. Don't be afraid. It'll hurt you more, hurts me. Plug the Arduino in. Now, oops. That's not very helpful, is it? How's the best way to? So turn around so we can. Now, apologies for the clarity of the LCD. Finding one with contrast that works with my cheap camera was a bit of a challenge. So right now we're running at an output of 10 megahertz. Nice frequency to use for a whole range of purposes, right, Rex? And if I go back here and find the recent script sketches, it was that one. So let's get rid of that. No, I don't want to save the example. Now this is a different device to the one I showed you before. This is an Arduino Nano. So we change it until the Arduino environment what it is. And then I tell it what port it's on, and that's actually on USB 0 because the USB connector, so USB converter chip on is different to the one on the classic Arduino. I have a frequency counter connected down here, and it's got some frequency of 10 megahertz. If I go over here and tweak the rotary encoder, a few issues there with switch debouncing, unfortunately. Bit of frustration, that's how these things go. But if I go back to the display, you can see the code itself looks a little bit intimidating, but if I work through it, you might find it's not actually as scary as you may think. Now, I mentioned before pre-existing libraries. Now, these lines you can see up here are basically where I basically pull that code in and tell the Arduino environment, use this code when you make the program. Now, this one here, the SI5351, the signal generator is an SI5351 chip, and the library came from this site on the internet. Now, to do a bit of quick to show you what's going on there. If I go to Manage Libraries, I'll do what I did before, so I'll do it quickly, hopefully. Okay, it's downloading an update from the net to work out what libraries are available. SI5351 is the part I'm working in, and it said I've found 3 libraries that know about this chip out the box. The top one here is the one that Adafruit put out, which is fairly basic. It lets you specify the dividers for the various frequency generators. Bit tough. Don't like that. It sounds complicated. This JT encode one sounds interesting, but probably not for this application. But this one here, full featured, I like that. That sounds like a good thing to go for. But I want more information. Yep, it's already installed. Come on. Normally, when you click on that, it fires up your web browser and goes to the website and tells you more about it. This one caught my eye up your out, it's slow. That's all these cameras is talking to. It's worth doing 16 times. Yep, so it takes you to the source of the library. It gives you a whole range of instructions put up there by the author on how to use it. This library focused towards using RF amateur radio applications. Sounds like the perfect choice for me. Scrolling down, gives you a background, gives you some little snippets of code, understanding how to use it. Again, it's all within the environment. How to set it up, how to tune it, how to specify where the signal comes out. All the heavy lifting is basically done. You don't need to read the manufacturer's data sheet to work out what registers to set, any issues around ranges and values and all that kind of nasty stuff that makes life so difficult. Or, if you're like me, you're in a bit of a hurry and you just want to get knocked out in a couple of hours. Right. Close tabs. So that's already installed, that's why I can't install it again. Other libraries here, button debounce, that's just trying to work out why my numbers are, my stepping on the rotary encoder is not moving as smooth as I want. Liquid crystal, this comes out of the box, this is to talk to the LCD display. Now how do you set up the LCD display? You basically wire the various pins on the Arduino to the various connectors on the LCD display. You probably get the pin out from where you get the LCD display. Failing that, you get the multimeter out and start tracing signals. That's always fun. You tell the library this is where the various pins are connected. So register selects on 12, enables 11, blah blah blah. That's set up. Say the default frequency, 10 megs. This is an unsigned long number, big numbers. Arduinos don't like big numbers, it slows them down, but it's fast enough. Stepping, this is where so there's a couple of global variables, a serial buffer to accumulate text from serial port, I'll talk to that later. Then go to setup, so you say, set up the LCD display with 16 columns of text, 2 lines, right? It doesn't know how big, you've got to tell it, so it can do things like column wrap and so forth. Configure our I/O pins, just like with the blink script. I'm saying which pins are inputs, and these are inputs with a pull-up resistor turned on. That means fewer parts outside to solder in. Again, quicker way getting things sorted out. It does some work to attach an interrupt handler to those pins. An interrupt handler is essentially when your program is doing bits and pieces and something noteworthy occurs. It says stop what you're doing and do this code instead. Can make things a lot easier to understand until they go weird. You're debugging, and that's why I missed my debugger. Interrupt handlers are terrible when they don't know what you want. We set up the frequency generator. We initialize the frequency. Puts the text as serial port, and that's set up. Looping through, very easy. I've got a global variable which is controlled by the rotary encoder that specifies the frequency, so it's changed to the frequency. Now, of course, if the frequency hasn't changed, nothing terribly different happens. We do a bit of mathematics here to take that frequency, turn it from a number into some text that I can display on the LCD. That's an area where, again, the Arduinos have a bit of a problem. Working with real numbers, as numbers with decimal components, is computationally difficult and requires a lot of code to do it well. Arduinos don't have a lot of memory for this code, so there's a bit of faffing around to make it work in a small chip. But again, there are examples out there of how to do this. Finally, I check the serial port and do a few bits and pieces, and then loop back and do it all again. Now, one of the things that people get in trouble with is understanding how to use that loop function. The loop function is supposed to run again and again and again really, really quickly and try to do only what's necessary. Now, if you think about a person talking to something on a serial port, you want to type in a command and go enter and make it do something. If you try to read in a whole line of text and do nothing to get that carriage return in, it won't do anything else, which can make things a little weird and difficult to deal with. So one of the tricks around that is to don't do anything clever until you get the carriage return, but before you do it, just accumulate that data and save it away so when they do this carriage return, you've got a whole block of text to work in. That's what's going on down here. There's basically tuned to the frequency, a few support routines, the interrupt handlers mentioned through earlier. What does that mean what's actually happening? If I get a terminal emulator up and running here, and the window here showing this is the frequency counter connected, let's pick a frequency. Now we've got 10 megahertz. 10 megahertz. And if we go across to the display on the LCD, 10 megahertz. 12.34 megahertz, that's a nice number. Frequency changes on the display. Now, when I mentioned the complicated things about a serial port, if I go here, let's say we got 100 kilohertz, the display hasn't changed on the frequency counter. If I go back over to here, still 12.345, I can go back over here just to the dial around randomly, pick another random 12.77, just the number. Frequency output's 12.77, but because I'm not going to do anything until I get a carriage return from the input, nothing happens there. Press return. So again, the trick is it's a bit of a thinking about how that loop function works, keeping the code concise. Don't do anything unless it's really needful, to use that interesting Indian mechanism, and just try to make it nice and neat and tight. So thinking about how you do things in a particular order, the point where you do the complicated code, just kind of keep the loop function nice and short and condensed. Didn't see the rounding issue, thank you. Again, real numbers don't always present nicely as binary numbers, and sometimes when you do math on these things, the divisions don't quite come out right. You see some rounding numbers, so sometimes I'll see 10 meg, sometimes 10.001. It's like, okay, we're being difficult. This is a gotcha. This is more code, not impossible. Just again, I didn't have that much time to go through and polish it off, so this is just exploring what the chip can do. I have mentioned before other Arduino variations. This is more of a show rather than a demonstrate option. That microprocessor there, like I said, 32K of program space, 2K for data. That's not a lot to do something clever. You certainly can't do anything in terms of heavy internet type activity, running a web server. This is something that can. This is a garden sprinkler controller. The module you can see there, $6, $7 from our friends in China. It's essentially Wi-Fi on here, so I connect to my home wireless network or to the club room wireless network if I was doing something silly. The code that's running in there was written on an Arduino in the Arduino IDE. I just told it, here's where to go off the internet to download information about these particular boards, because someone's done hard work. Everything I know and learned from using those smaller Arduino IDEs applies to this. Same tool set. Many of the libraries I'm using are the same. Many of the code examples are from other chips. But because people have been working very hard to make their code portable and building on other people's success over the past 15 years, this stuff uplifts and works. So again, you're working for a platform where a lot of difficult work's been done by other people, and you just get to inject your ideas. So that's a $6, $7 Chinese module. That's an I2C connected real-time clock. I2C is really, really good because unlike things like the Mega I showed, all those nice I/O connectors, this guy underneath, look, that's that module I mentioned. Those two wires coming off, the white ones, that's all the I/O I'm using. It doesn't have very many pins to work with, and of those, there's even less. But the I2C bus, because it's a serial bus, it's worth understanding because it can talk at the same time to that clock module and this guy here, which is an I/O expander, which is driving the relay control board. I can add more of these. I think the way that the I/O expander works, you have a maximum of 8 of them connected in series for you. You have to pick a different chip. That's 64 bits of I/O, which is more than this guy can do. Not as fast, but again, it's all about maximising the I/O and picking the right chip for the job. That was $2 or $3, I think, but not terribly expensive. The relay board here, $12 from eBay. All the hard work is basically done. It's download the example libraries for the internet, look at people's code examples, work out how does my idea fit using those building blocks, and go off and do it.
So your expensive parts are 24-volt AC power supply.
Yes. Unfortunately, the 24-volt AC power supply I'm using to run this thing came with a control panel. It cost me like all up about $100. So I'm throwing a $100 sprinkler system to replace it with a $50 sprinkler system, which is more capable. But that's okay. This is all about fun. And it'll be a better product, I think, than the one I bought from Bunnings. That's another conversation. These are my recommendation to anybody thinking about getting this space. Get into using these small gadgets because there's 15 years worth of stuff out there to tinker with. Learn to use the environment, and then when you grow beyond those limits, look at some of these guys here. There's a whole range of tools out there, boards out there, which do even more. This is, I think it's a Tensilica CPU or some unusual little thing. You might have heard of ARM CPUs. These are the guys used by Apple in their iPads and iPhones. There's a STM Arduino project out there, which is basically making the STM processors usable in the same Arduino environment. I've seen those boards down around $2 a pop, and they have more memory than these have, and they run like stink. They are really, really quick.
And free shipping.
Yes, and free shipping. It is one of those things where I think the limits really are your patience waiting for things coming from China, and what's your next cool, great idea. I think kids these days have really cool things to play with. I wish I was a teenager again, maybe.
Sean, back on your sketch
Yep.
for the frequency counter, would you mind bringing that back up again?
Yep.
Right up the top, one of the include ones, I think, is the I2C, the Y one. There,
Correct,
Y.H.
yes. And that's in the environment from day one.
Yeah.
So
And is there any more references to that further down, or once
no,
it goes?
the reason you don't see any references beyond that is that the wire library is needed because the SI5351 depends on it.
Yeah.
So you include both, and then you just use the SI5351 library, and that hides everything away. So that's literally instantiate the variable, if we can say that. Then you tell it to go off and initialize itself. Where is it? Here, where you tell it this is the load crystal on the oscillator module to use, and the other options I think were which output to use and the correction factor to apply to the clock. It's got a 25 megahertz crystal somewhere on that board. There's clearly no TCXO or anything really stable in that environment, so you can compare the output against a real-time source and say add or subtract so many hertz and get something closer to an accurate time. But again, you've got all the environmental factors and so forth, and it's a case of, well, it may not be what we're looking for, but like I said, this is being used for the micro bit-X transceiver. It's good enough, I guess, for QRP purposes. Not good for microwave use, but the frequency range of this is actually quite low. That module, I think the upper frequency limit is about 200 megahertz.
But if you can do the comparison, you'd be able to feed 10 megs, stabilise 10 megs, and then do the comparison and the correction. So
You need to get some t-shirts printed for that. 10 meg everywhere.
10 megs
Actually,
rules,
sorry,
doesn't it?
actually, no, I did mention that good questions get a prize. Catch. Larry.
The 5351 has a 25 or 27 megahertz crystal. It's that little silver thing. It's hardly visible. And if
I'll take your word. I can't see it. I'll take your word for it.
Yeah, if you're careful, you can strip it off. And the 5351 chip has an XA and an XB input, which is the crystal input. So one is hot, one is ground, essentially. Yep. And I've stripped off. I have not yet done this, but I've stripped off the crystal. And my intention is, if my skill set ever gets good enough and I take enough Valium to not jiggle around, I should be able to put a 10 megahertz reference into the XA, which will overdrive it, and you'll have 10 meg GPSDO locked with pretty much any frequency you want up to 200 megs with GPS locked. It's doable, by the way.
I fully believe it's doable. For those people looking at this board, bring it up.
I got a half a dozen because I think I was going to make some mistakes. The soldering iron is about as big as half a
How can I
component.
point it out? What have I got for reference? I've got a pen. Thank you. Okay, standard off-the-shelf biro. That thing there is a chip in question.
Yes.
So it is bigger than a match head, but not by much. I admire your Valium, you reckon's a trick.
Well, I got it off with a little bit of heat. Getting the wire on there is going to be like Ron doing his little...
That'd be easy compared to the
So, Larry, does that count as a question, do you reckon?
Sorry.
Don't cut it.
Thank you.
I guess, do the plug. If anyone's thinking about tinkering these things, seriously have a look at stuff on the shelf at JCar. I was out there late last week, and they've got books, quite a few books. They've got boards, they've got shields, they've got plug-in bits and pieces for the experimenter kits. They've got the experimenter kits. It is actually surprising, given, I guess, previously you see JCar investing so much in this area. They must smell opportunity. As a get in and do stuff, it's great. I mean, I think they're doing really good work in that space. And if you want that instant, I want it right now or tomorrow morning, really can't beat it. You only get one board.
That's okay, it's okay. Now, I wanted to mention this little Adafruit board, I've got about 5 or 6 of them because I knew I'd be making mistakes. They have 3 outputs, as you said.
Yes.
And the only part I haven't figured out, which you're giving me a clue to now, is how to get all the multiplier divisors, or whatever, so that I get the right frequency output.
Yep. The
And
answer is
is that in that software?
Use that library and stop thinking about the model. Just say the frequency, literally. Where's the...
Well, the whole idea was if I had 3 outputs, I could drive 3 different things with GPS lock. So we're looking at maybe a transverter versus a converter versus something else.
This line here...
All out of one little $5 board.
Yep, set line highlighted here. That's saying set this output, clock 0 to frequency, whatever it is. I'm not specifying dividers. The guy at the library thought, that sounds like silly hard work. There's got to be an easy way to solve that problem. So, again, that's the beauty about this whole ecosystem. You've got people going, that's good, I can do better. The libraries come out, and all of a sudden your work or your problem becomes a lot easier to solve. Any questions? Mr. Short.
Aside from the fact they're super cheap, being probably someone who hasn't coded for a while, how easy are these things to accidentally break, and can you recover from Can software brick the board?
In answer to that question, these ones I'm checking right now.
Yep.
You seem to be able to do that. I've got a program at home that when I download it into the module, it doesn't work anymore.
Right.
It's not an unknown problem, and when I've got a good solution, I'll happily share it with people, but it is a little bit frustrating. The Arduinos themselves, the AVR chips, you've got to basically let the blue smoke out to kill them. The bootloader, you can't overwrite from your program unless you're really making an effort. And like I mentioned, you can always take another Arduino and reprogram it and put the bootloader back. To give you an indication as to the interesting bits on that, most Arduinos you'll see there's this funny little 6-pin header. There's one there where you can use the Arduino in-circuit programmer or a sketch on another Arduino to re-download the bootloader there. It's annoying, but again, it's one of those things that you do it a couple of times, you get over it. But certainly, I've never ever damaged an Arduino, one of the AVR ones, by software.
Okay.
You're doing pretty clever things to pull that trick off.
Yep.
Because
It's worth noting too that there's quite a few drones and UAVs that are powered by Arduino.
yes,
In fact, Ron's presentation he did, that was powered by an Arduino-based autopilot. So.
that might have been one of the bigger, more powerful Arduinos, I suspect.
Possibly. That 6-pin thing, is that the same as the 6 pins
Yes.
on there? Right, okay.
The insert, it's an in-circuit serial program header. There's no formal standard from Atmel regarding how these things should be wired up, but there's probably two de facto standards. One called Candor, which is essentially a 2x5 header where it's got the serial connections, it's got power and ground, and I think it's got a signal to an LED on and off to prove it's connected. Some people say 10-pin headers are too expensive, let's do 6, because a lot of those other 10 headers are ground things, and it's a 6-pin version. You can buy a converter that goes from 10 to 6, and JCar sell those as well. You got one of these? This is... Okay, how about any not so good questions?
If anyone's interested, the libraries are basically C++
Yes.
modules with some indexing files generated out of them. So if you know that, you can do the modules.
It's one of those things where as you start tinkering around, you find yourself taking other people's C++ libraries and basically shoehorning and to fit them in there. Again, if you want to do things quickly, so take else a good idea and work with that. But
Is that what board you're recommending as a starter? That one that's on there now?
I recommend those, yeah, because if you've never done this before and you're looking at other people's documentation, it's always got something on in front of you that looks like what the pictures say. Again, the I/O I/O shields and so forth, are designed to fit on that. So if you want to do a breadboard header or other bits and pieces, buy it, stick it on, and focus on the software side. We're worrying about where's the soldering iron and all that bits and pieces. But of course, once you've got things working, that place you might say, this is too big and bulky to fit in my problem. I want something small like that, or even smaller like that. Or if you like Larry, who can do the really small packages, you might want to actually do the micro ones. But I give you.
There's one smaller than that. Because there's the ones that don't have the USB on them.
Yeah.
They've just got the USB header. So you buy a USB module, you stick it on the header, you program it, you take it off, and it's that size. It's postage stamp size. So if you need a little embedded controller,
Goody smaller.
Yeah.
and it's basically just the Atmel with a little bit of glue, and that's about it, and a couple of headers.
If you wanted to drive a stepping motor off one of these, are there high current drivers you can get in the same way as you can get
There are stepper motor driver shields, so you can Google one of those and go click. Where's my example code? Go for it.
just dial up what step it is per degrees and
Yep.
all that sort of stuff. Yeah.
Other options in that space, if you want to move away from the shield form factor, there's a company called Pololu who work in this robotics space, and they will sell you a stepper motor driver module which does all the hard work in terms of step counting and so forth, and speed, acceleration on chip. So again, use their libraries, use their module, and let them do the hard work for you. There was another company, I think, called Trinomics, who have a Pololu compatible board, which is the coolest thing I've ever seen because it drives stepper motors using analog rather than digital, so it uses a shape sine wave rather than square wave. the beauty of that is there's no jitter, so for things requiring accuracy, there's basic no flapping around, and they're dead quiet. All the noise step noise comes from that square wave coming through. These don't square modes, so you look at it, it just moves. It's like, what's going on? That can't be right.
What was the second name?
Trinomics, I think it's coming.
Okay.
So I think this is seriously really, really nice. But again, their stuff's good but expensive. The Palolo boards are common. They've been claimed by quite a few people. They're available. I think Tronics Labs sell Palolo bits and pieces as well. I know Little Bird Electronics do. Failing that, you could always get, I guess, one of those generic off-the-shelf H-bridge modules you can get from the likes of eBay and just wire up and go that way. Again, those things, you can't buy the parts what the modules cost. They come with the screw headers and circuit boards with mounting holes. It's like, yeah, I'm not going to get them. I'm lazy. Let them do the hard work.
Thank you.
Have you got much in the way of the Internet of Things, like shields for?
Yep.
Arduinos?
The chip I showed you here, that's there's a range of these chips called ESP mod, ESP 12, 12Es, 12Fs. That's one way of packaging. Another way is a little tin box. There are Arduino shields with those tin boxes already on them, so you can use this kind of Arduino to drive one of those modules. But it's kind of I find it annoying because the smarts in the Wi-Fi shield significantly blow this thing out of the water, and you put the Arduino code directly in the shield anyway. So it's kind of like it's kind of annoying. It's just totally it's weird. I mean, the code there for the Internet of Things, they're certainly smart enough to talk to external web-based services. I've used those to talk to things like Things board for gauges and so forth, just reporting temperature and light intensity and humidity and so forth. You fit that kind of code in one of those ESP modules, and out of the 1 megabyte of memory uses for code, I think the biggest I've done is a quarter of that's being used. It's after a while that all the work's done in the libraries and your glue, I guess you'll call it, together. It doesn't consume as much space as you might think.
Yeah. Okay.
But that was just the Wi-Fi. Is there other IoT connected things like can you get a LoRa board for it? Or
Too much dinner tonight.
Sorry.
Yeah, I think I've seen a lot of
that wasn't asking you to Google it.
I'm pretty sure you can. I mean, it's
I think
Because I-
JCar had a whole setup where you could actually buy the thing with the lower board on it, sort of ready to go.
Okay.
Bit of a
Oh,
promotion.
JK did.
Yeah,
Oh, cool. That answers that
a
question.
little shield to go on.
it's one of those things. Literally, if I've got something to do with an Arduino. Google Arduino, my thing, and see how many tens of hundreds come back. There's a lot of stuff out there, and a lot of it's not so much has anyone done it. It's who's done the best, and will it cost me anything, and will it actually cover everything I want, or got to tweak it anymore? 15 years is a long time to take an idea and make it great.
Yeah.
Or do you want to go to JCar and buy one now? I would be very surprised if you couldn't just hack straight into those Wi-Fi shields and do things from day one.
Things about that. Sorry, when you mentioned about programming, just the bare bone Apple chip, like it's amazing how much you can pay to get a programming cable to do things, where you can get a cheap Arduino, flash it with a bit of code, and there's your programmer for under $10.
Yep. The Wi-Fi modules, one of the bootloader options is program over Wi-Fi. So if you have the basic code, then you get up and running, and fine, I'm doing it over my wireless network, I don't need cable anymore. But it's,
So you're connecting to it over the Wi-Fi.
Yep.
So you're not soaking the serial port of that program.
once it's up running on the air, there's enough smarts in the bootloader to go, oh, this is code, it has banked memory set aside, oh, I'll use that bank of memory for the downloaded program, then I'll flip in and boot off that. So basically you can flip from one to the other over the air programming.
You go on a web page off that ESP one.
I'm not
right?
sure I understood that.
That ESP module,
How do you connect to it and send a new sketch to it up?
initially you need to do the connection with your USB port to get code on there. Once you've got the stub on there, you've been basically connecting. It's scary. Who hacked my fridge and turned my washing machine on wax?
And then the sprinklers.
I don't want anybody trying that, Ron. Thank you. Two more.
What speed was it on again?
My house is going berserk.
Or is this another bug in my code? More likely the latter, I suspect. Sprinklers aren't that much fun.
Can you get a shield that takes a SIM card?
Yes.
Yes.
Definitely.
Yes.
So basically, you could have something completely remote, put a SIM card in it, and basically talk to it via the mobile phone network.
Or have it reporting back data, or turning a pump on or off, or reporting solar battery. It's again one of those areas where the ideas, the building blocks are all out there. It's what's your idea and what are the bits you can put there and make it happen.
Remote radio station.
Turn it on and off, probably.
I guess it depends how much you wanted to interface to it, how much communication you wanted to send back and forth.
And
I'm
how
guessing you're not getting very far towards a maestro.
Yeah.
Just saying.
Any more questions? I've got one more to go to a good home. Come on, guys. Cool for me. Like I said, everyone's got any questions, see me later. You're on that up here most Wednesdays, so if anyone's tinkering one of these things and has any questions or an idea, then come and see me, please.
That's right. Wednesday nights are all
Yep. But thank you very much, people coming up. It's I guess it's a cold, dark night outside. It's always fun driving through the wildlife in the dark.
Not literally, of course.
Not over the wildlife.
Depends on where you live in the country, mate. Thank you very much, boys. Thank you.